Deep Impact Chopra.
Deep Impact Chopra.
Deep Impact Chopra. The galactic nuance of the four-headed dinosaur of the Earth has so it sits around.
The sky is falling.
Yeah. Oh, the sky is falling. Is that what you said?
The sky is falling.
It scared me. So, you probably have heard about this big rock that fell from the sky and hit Russia, maybe. It's been on the internet.
Parts of it hit Russia.
Yeah. You're going to make me a liar for parts of it hit Russia?
Well, most of it exploded and vaporized.
Okay, well, whatever. It exploded over Russia.
Okay.
And listen, if we're going to cash in on anything to get hits, this is it.
Yeah. So, Earth has suffered an impact. It's not a deep impact.
But some of it did actually hit the Earth.
It
actually landed in a lake.
Yeah, so this is formally going to be known in the history books as the Chebarkul Meteor Event or the Russian Meteor Event. Essentially, this meteor flew in and exploded with the force of, it was a couple of times larger than Hiroshima, but it exploded so high in the atmosphere that it only managed to blow out windows and frighten people.
Which is pretty amazing, because it was like 50 kilometers up, right?
It was anywhere between 50 and 18 kilometers up. There was a bit of a... Because there were two explosions, you can say.
And it was coming in at an angle.
And it was coming in at an angle, and it exploded, and boom, boom. Okay, so this thing exploded, but it happened at a really crazy time, because 15 hours later, Earth had a really near miss from another asteroid called DA-14.
Another asteroid?
Another asteroid. Now,
was this meteorite an asteroid before it hit us?
Meteorites are asteroids before they hit you.
So meteors are asteroids, and meteorites are asteroids that have come into the atmosphere.
You have different classifications for these kinds of events. You have asteroids, which are kind of near-Earth objects, or just anything kind of out in space and not really interacting with the planets or anything. Those are just the big amorphous blobs of rock and iron.
Look like giant potatoes.
Yeah, the big potatoes in the asteroid belt. It's not called the meteor belt, although they are very similar. Meteors are what happens when an asteroid actually enters the atmosphere. Then it's called a meteor. And it's called a meteorite when it hits the ground and actually leaves an impact crater. Then you can actually pick up some remaining chunk of it, presumably, and you say, this is a meteorite. But it's a meteor when you witness it in the atmosphere, and it's an asteroid when it's outside of the atmosphere. So that's a neat little distinction to make. The thing in Chebarkul was actually called a super bolide. Now, a bolide is a meteor that has a long tail. Okay.
Yeah.
And the tail is caused by the friction of the atmosphere, and the ablated bits sort of blowing off it and stuff, and creating like a dust trail. But it's also caused by plasma, superheated plasma. That's what the fireball part of it is. The cool thing about plasma is it's actually made of charged particles. Right. Plasma is actually a bunch of ions, atomic nuclei that don't have any electrons around them.
This is like a state of matter beyond
exactly.
gas.
Yeah,
right?
beyond gas. It got so
solid,
hot.
liquid, gas, plasma.
Yeah, it got so hot that all of the electrons got stripped off the atoms, and now you just have like a bunch of protons sort of going around, and it's very reactive, and it's very hot, and it's very horrible to get very close to it. Okay. Now the really cool thing is, if you look up at the night sky, if you're looking at maybe the Perseid or the Leonid meteor shower, you'll see these things sort of come in and they sort of zip across the sky. And sometimes you get ones that have like a really long trail on them, and those are called bolides. And the cool thing about bolides is, since they have this charged particle trail on them, it's charged. So as it's tearing through the atmosphere, it's also interacting with the Earth's magnetic field. And it causes magnetic eddies to actually ripple off the ground and sort of bounce back up into the ionosphere. And these eddies actually happen at sonic wavelengths. So even though it's an electromagnetic frequency, it's between the 20 hertz to 100 kilohertz range. All right? And that is enough to actually cause bits of debris laying around you to shake, even your hair against your glasses to actually sort of vibrate.
So when I saw a meteor many years ago in Prince Edward Island, and as it shot overhead, it had a bolide trail, it sparkled, it was absolutely beautiful, and it actually kind of made a
Yeah.
So that's not it actually.
No.
Fizzing.
Yeah, the
it's
cool
stuff
thing,
around
it's
me
stuff
fizzing?
around you. It's probably even your hair against your glasses just sort of vibrating. It's such a physics kind of cool thing that they gave it a name. It's called geophysical electrophonics. Okay, and the idea...
I'm hooked on geophysical electrophonics. It's my next t-shirt.
Nice. Now, we know that you couldn't have possibly heard this thing.
No, exactly. It's too
because,
far away. And
yeah, because
traveling
it's like
too
100 kilometers up as it's zipping through the atmosphere. And we all know that the speed of sound is much slower than the speed of light. So even though you see it as being, an almost instantaneous event, we all know that, even a lightning strike a couple of kilometers away leads to a couple of seconds delay in thunder.
Maybe
so,
you watch an aircraft take off
Yeah.
in a distance.
So we would expect to see something like that, but we don't. Instead, we see a zip of light and an instant sound. And that's because everything around you is resonating with the sound of that thing tearing through the Earth's magnetic.
That's very cool.
Yeah. So anyway, that thing came in,
Yes.
screeching in at 18 kilometers an hour, 18 kilometers an hour.
50,000 kilometers an hour.
It passed a school bus on its way down.
18 kilometers a second.
18 kilometers a second. It impacted the Earth's atmosphere with such force that it actually exploded with the force of half a megaton bomb.
And if you've seen the videos, it happened early-ish in the morning in Russia.
Yeah.
And everybody in Russia has a dash cam because they're all...
Because it's Russia, and that's what they do.
Their insurance rates, I guess, are crazy or something, and they want to have the proof that the guy in front of them actually killed them. Anyway, with the dash cams, most of the video that we've seen is from these dash cams.
Yeah.
And you can tell, and we could probably put a key up here.
Oh, look at that. Dash cam?
Yeah.
Oh, wait. Dash cam?
Nuts.
Security.
Now what's interesting about this picture is...
Oh, yeah, security. What's the name of this place?
This is Chelyabinsk.
Chelyabinsk.
Which is, of course, in Russia.
Yeah.
This is a picture of Revolution Square, which is in the dead center of the town. There's a guy out there...
Yeah, in Internetville.
...who has done something I think is absolutely amazing.
Yeah, he's used the powers of science and trigonometry. Trigonometry, okay? It's not just for video games, and it's not just for, doodling booby pictures in math class. It's actually a really useful tool when you want to figure out the trajectory of a meteor that exploded in your hometown.
So he took this video from Chelyabinsk, combined it with a Google Earth.
Yep.
Because he has the coordinates for this square. He knows exactly where it is.
Yeah, and he knew exactly the time of day, so he knows the exact angle of the sun. And
he used some high school trig. And
yeah, basically, it's really cool. You can see, because of the lampposts, he knows how far apart the lampposts are. And you can see that the shadow from the meteorite, as it's coming down, you see them actually moving, but they're not all parallel. They're kind of like this, sort of like this. That's using trigonometry. You can actually calculate those angles and figure out how high up it is and how far away it is.
And he actually he plotted a grid. He made a GIF that'll show you what he did, which you can show, right?
It's a freaking cool GIF here.
It's very cool.
Yeah.
Showing you the angle.
Very triangly.
Yeah. So without leaving the comfort of his own home,
he used his pee-pee as a sundial.
Without leaving the comfort of his own home, he triangulated the pretty precise trajectory that this meteorite took. And when he laid it all out, you go to his website, it's ogle.com. Ogle is in ogle. So this guy's use of Google Earth, high school math, and what else did he use? Some surveillance footage.
Yeah.
He was able to map the trajectory so precisely that it matches up where the meteorite that actually hit the ground like in his map. It was right in
where the remaining meteorite
lake.
Actually landed. It landed right in what was the lake called?
Chebarkul.
It was a Chebarkul Lake?
Chebarkul, yeah.
Huh.
So that's pretty impressive work. But now the question is, had that meteorite exploded a little lower in the atmosphere, say at a kilometer, what are we talking about in terms of explosive force?
500,000 kilograms of dynamite. 500,000 kilograms of dynamite. So the fact that it was like 18 kilometers away and it actually broke windows, set off car alarms all over the place, and thousands of people were actually having to be treated with broken glass injuries because the windows that they were looking at this thing through, because it came streaking in. They're like, oh, look at that, let's all rush to the window, and then, oh, my face.
Except they were saying it in Russian.
Oh, yeah. Probably. I don't know. I'm not Russian. But the reality of the situation is some people who weren't actually looking at it through windows could actually feel the heat from the explosion.
There was a concussive force.
There was a concussive force, but they could actually feel the heat from this thing as it actually, ignited in the air.
So 500,000 kilograms?
Kilograms.
So that's
like a half a megaton.
Half a megaton. if that had exploded at the optimal height to explode a bomb,
Yeah.
they would have been bigger than the explosion
wiped
that happened over
Hiroshima,
and
yeah,
Nagasaki.
yeah, combined even.
Right.
You know, it would have completely decimated Chebarkul, like completely, just nothing left.
And what caused it to explode?
Ablation and most likely a steam explosion.
You have to explain ablation.
Ablation is, well, I already explained it in this
Are
episode.
they going to flip back?
Oh, okay, maybe they won't flip back.
Just do the elevator pitch for ablation.
Ablation. This is when you have like a crazy rubble pile of an asteroid that's kind of made out of loose rocks, bits of ice and iron and stuff. As it's streaking through the atmosphere, it's gathering a lot of heat on its outer surface, and it's also, you know, it's gathering heat because of the friction, but the friction actually causes fissures in the surface, and sometimes those fissures cause huge flakes of the meteor to break off, and it'll expose its cooler and gooey insides and actually cause all of that methane and water ice and all of that to just flash, flash sublimate directly from a solid to a gas in under a second. And that's what causes...
And that's why it looked like a fiery explosion.
That's why it looks like a fiery explosion, because all of this stuff, those temperatures are actually hot enough to cause water to electrolyze. So it's hot enough to cause the water to break into hydrogen and oxygen, and then as it's doing that, it's exploding, and then when it reaches the outer limits of that, it's turning back into water vapor, and then exploding again, because hydrogen and water reactions are actually really energetic.
Hydrogen and oxygen reactions.
Hydrogen and oxygen reactions are really energetic. So yeah, that's essentially
what's pretty exciting.
It is pretty exciting. Now, as to whether or not that's what caused this explosion, it remains to be seen, because they actually have to start studying the meteorite to make sure, just to test what it was actually made out of.
And the core of it, I mean, in all likelihood, all that will remain is an iron core, ultimately.
Yeah, it would be whatever was left, whatever could make it through the atmosphere after everything else can. They said there were thousands of smaller meteorites that actually hit the Earth, but they hit the Earth at terminal velocity, which means they weren't heavy enough to overcome the friction, and the friction of the air as they were passing through it caused it to not go any faster than like maybe 700 kilometers an hour, which is usually what terminal velocity is around.
Parts of the meteorite are being sold on eBay right now for astronomical,
Zing!
It's a physics joke or something. Astronomical prices. A piece about this big, I know you can't see it, but smaller than a golf ball, was sold in Japan for $17,000. And there's no way to prove that I could be selling rocks on eBay. If you see me selling rocks on eBay, don't buy them. I'm telling you right now. Or should you?
Well, I guess, you know, it goes to show. I mean, it even speaks to like celebrity culture. If you explode on camera, whatever you touched is going to be worth a lot of money. Britney Spears, I'm looking at you.
That's excellent. How did you bring Britney Spears in?
I don't know. Goobers. I'm Dave Noel.
I'm Rod Weatherby.
And you're watching Nutshell.tv. Oh, no, shit.
Oh, what?
Oh, no. Okay, that was only the first part of this. This is a big story.
Oh, right. We've got more. Okay, we're big enough to split this up.
Okay.
Do we want to do it?
Okay.